I noticed this thing was doing a little bit of fluttering. There's my nose. Okay, we're in focus. So, yeah, I saw your hand like this, Josh. So we're going to call out the road. It's a bit of an exaggeration, but if I draw it to true scale, it won't look very tilty. So, thank God there aren't many roads like that, although I'll show you a few today. So your car is going to be like here. For all of you that drive 1986 Buicks with tiny wheels and Chopper's little windows. And no hands. So, there's your car. Okay, 6%. Where is it, my friend? Go ahead. Or anybody else for that matter. I heard angle.
It's between like a straight line and the slope of the C line.
Put 6% grade up here. This is what we're trying to define, yeah?
Yeah.
And then I just heard the word slope. I also heard the word angle. Over there, your name is, my friend?
Brittany.
Brittany, go ahead.
I was just going to say the same thing.
You were. Okay, so say it again for me. Go ahead, Brittany.
I was just going to say, like, if you were to be traveling on a straight and level road,
yes,
then it's saying that it's going to, like, if you were traveling up, it's going to increase by 6%, and if you're going to travel down, it's going to decrease by 6%.
6%, sure, if you turn back around. Absolutely. So where, I guess my question is, where is the 6 in that picture?
Between the straight line and the angled line.
So this is 6%. I do agree with that. But if you had to measure that 6%, because we don't usually carry percentage rulers like in our pocket, if you had to quantify that for someone, where is the 6%? Like, I agree that it's there, but when you talk about angles, when you guys talk about angles from geometry, you don't use percentage usually, do you? What do you usually use? It's degrees. You use degrees. And that's not 6 degrees.
The intersect, it would be 180, or no?
The intersect would
Like,
be...
like 180 would be straight up and down.
From horizontal?
Right.
Well, technically, I mean, speaking of geometry, if we were to do that, what's that right there? Technically.
That's
90.
That's a chord, technically. Sorry about that. Computer, I unplugged it too. I apologize. It's bright white against the black floor. How did I not see that? I don't know, ADD. Okay. So that right there, I'm going to put a square there. That's 90 degrees. Can we agree with that?
Right.
Now, tell me your name again.
Amy.
Amy. The 180 would be if you put another one over here. A straight line is defined to be 180. There's all kinds of little geometric things you probably learned at some point in your life. Like, let me do this. Hold my pocket. So, let's put like geometry notes up here. Geometry notes. These can come in handy. So, straight line, 180 degrees. We can agree with that, right? Straight line's 180 degrees. Perpendicular line. We like these in mathematics. These are good. Because a lot of times when you think about any kind of location software you use, like compass coordinates and things like that, north, south, east, west, they're at 90-degree angles. East to west is 180, north to south is 180, but a lot of times, like bend is, I'm going to ballpark this, it's at like 121 west, 44.5 north, or something like that. Some-ish, somewhere we can Google if we need to. So it gives you these, they're called orthogonal coordinates or perpendicular coordinates. So I'm going to do perpendicular, if that's okay. Perpendicular or right-angled lines are 90 degrees. Is that fair? You guys remember that from your geometry? Sorry about bringing back geometry and like torture you guys. We're going to do a little bit of geometry in this class, just a little tiny bit. I promise, a little tiny bit. It's stuff that's useful. We're going to measure trees and stuff like that. Stuff that you can measure mountains with, the geometry we'll talk about. But that's all. Maybe a little bit of Pythagoras too. Maybe not today. Yeah, yeah. I heard like, yeah, let's do it. I like it too. I think it's beautiful. We'll use it when we have to use it, not if we don't have to. Speaking of Pythagoras, did you notice I drew a triangle? Just kind of putting your guys' ideas together. So when Josh is like, draw the horizontal, and Amy said, draw the vertical, or Brittany, I forget which one of you said, draw the vertical or the horizontal. I made a triangle, right? Tell me about this angle, triangle, 3 angles, that angle, and that angle, all together.
They equal 180.
You remember that from geometry? The three angles of a triangle add up to 180? You don't remember it?
No, I just said it, that's why I just.
Oh, okay. Well, some of you remember. I saw some nods. Yes, we kind of remember that from back in the day. We probably proved it at some point. No, that's okay too. You don't have to prove it. The three angles of a triangle also add to 180 degrees. And honestly, that's all we're going to need for maybe even the entire class as far as that bit of geometry goes. There's a lot of other stuff, like there's some cool stuff, you probably figured this out already. If that's 90, what do these two have to be together? They could be 45 and 45 if they were equal, but even if they're not equal, very good, I like those too. Some of your roofs might be like that. But even if they're not equal, what do they have to add up to? They would have to add up to 90, right? Because if this is 90, and this plus this is 180, 90 of it's here, the other 90 has to be there. Now that doesn't help us figure out what that is. If we knew that, yeah. But how many of you in your car are carrying a protractor? Wait, honey, pull the car over. I gotta pee and measure. Hey, you don't do that, right? You can figure it out, but usually not like that. Okay? So we'll keep that on the back burner. It's gonna come in handy. We do like that. So I saw a hand pop up. I'm sorry, I did see a hand pop up. Tell me your name again.
Matt.
Matt, I'm gonna guess Matt. Go ahead.
Yeah, this is just kind of shooting out there. Well, would it just be 6% of 180? So can you just multiply it by 0.06?
So this is where we fall back into, this is how it's defined as. What Matt just did was he postulated what's called a definition in mathematics. There are different kinds of things in mathematics that you have learned throughout your time in mathematics. Certain things are called definitions. They are set up to be that way because we set them up to be that way. There are certain things called theorems. Do you remember that? The idea of a theorem, a Pythagorean theorem. Why is a Pythagorean theorem a theorem? Anybody know why? Say that again.
Because it's not always accurate.
Tell me your name.
Megan.
Megan. Because it's not always accurate. Mathematically, it's the opposite of that, believe it or not. It's always true because you can prove it to be true. Now, that's different than a theory in science, right? The theory of evolution. You can't prove it. You can observe support for it, but you can't prove it. The thing about a theorem in mathematics is it's true beyond any reasonable doubt because you can prove it in all cases. The catch, and this is probably what pissed you off in sophomore geometry or junior geometry or freshman geometry whenever you took it, is that theorems at their heart are based in definitions. So they're only provable against all odds if you accept the definitions they're built off of. Just like anything else in your life. Think about it. Whenever you have a discussion or an argument with somebody, and I don't mean a bad argument, I mean a discussion and a back and forth. You know the stuff that politicians don't have anymore? Just back and forth where everybody learns? You ever watch a debate from like 1970? Like a presidential debate from the 70s? Watch it sometime. It's crazy, like, wow, they seem to like each other. It's not all about slander, it's about learning and discussing and having this back and forth. So a theorem in geometry, like Pythagoras, is based off of definitions, which brings me back to Matt. The definition of grade. What you just described is a perfect definition. It's just not used. It's just not used. It's not, the 6% has nothing to do with the angles of the triangle. There's a relationship, but it's not based on those angles. But thank you for that. It's an alternative definition.
Ashley?
Ashley, go.
Is it the rise over run?
That is the definition that grade is. Yes, ma'am. Yes, ma'am. That's why I was so excited to see slope. I'm not saying it's not tied to angle. We'll talk about that today too. But the grade of a road is the same as the slope of that road. Let's swing over to the sideboard over here and make sure we have that definition, because that, if we got that, we're golden. And then we'll use it for the rest of the day, and probably